Safety. Harper, Fiat, Warner, Brody, and Helen.
You're so raw.
No, it's only one. No, votes can take out the safety.
All right, guys, you ready? All right, so. Oh, actually, keep talking. Why? That's okay.
I do this. Did they print out your schedule for you?
Yeah, but I love.
I can print you another one.
Dude, I'm gonna be fantastic. I'll have to save one for you.
You came from Berkner? I used to teach at Berkner. Uh-huh.
200, walk the curve. It's 4. That is bad. I was like. That's not bad, man. We gotta go with. It'll be football right after this.
Okay, it's gonna print right across the hall. I'll get it.
Okay, you had it. Green card. Hey, this is why.
It's 11. Why? And like, so if I don't want by wrong.
Bro, I've actually been on the come. Dude, you've been on the come now. No, Brody's lost like 6 in a row. Nobody got that's what they do. Look, it's very fun game, not players and actually. Just impossible. Oh, no way, this dude, bro. You seen him? Bro, look, it's like the tight end for what's his name. Dude. I'm trying to say go. All I need, I know.
Okay. All right, so y'all, this is like basically your last notes of new stuff.
Wait, the whole year?
Well, for the, like, 2023,
Oh.
So then we'll do a really short kind of like assessment on the 2 formula days that we did, and then this day, and then we're semester exam review.
Why you call it test?
Huh?
Why you call it test?
Cause it's not gonna be a test in the way we usually test. It'll just be like a assignment that counts. You know what I mean?
I see.
But it's a very easy day because we're doing sequences, which is basically just finding the pattern. Okay, so
We beat the last year.
yeah, you've seen it before. So a sequence. Okay, that's not a hole punch, but a sequence is just a list of numbers. They're in a particular order and they're gonna follow a pattern. And we're gonna call that pattern the function rule. Okay, the function rule. Okay, A sub 1, that means the 1 is kind of like a subscript, like it's small. Okay, A sub 1 refers to the first number in the sequence. Which means A sub 2 would be the what?
Second.
Okay, the second number in the sequence. And then A sub n would be like the end number. Okay, so that's kind of like your generic pattern. What we're going to use is the letter n to stand in for whatever number we're referring to. Okay, then the function rule is going to be the pattern used to find each number in the sequence. So I have 2 function rules listed below. We're going to find the first 4 terms to the sequence. So I want you to label them correctly. The first term will be called A1. And that means that I'm gonna take the number 1 and plug it into the function rule. So instead of 4n minus 1, it's gonna be 4 times 1. And I said -1, I meant -2. Okay, so what is 4 times 1? And then take away 2 from that. Okay, so my first term is the number 2. A2, A3, and A4. We're gonna find just the first 4. But remember, you're always plugging that number into the same function rule, which is 4n minus 2. So I'll do 4 times 2 minus. What's 4 times 2? Take away 2 from 8. 6. Okay, for my third term in the sequence, it's 4 times 3 minus 2. What's 4 times 3? Take away 2. Okay, and then last one, A4 would be 4 times 4. 16, take away 2. 14. Then your sequence, you would just take those numbers and then list them in order. So you would say my sequence is 2, then 6, then 10, then 14, ... Okay, and sequences could be 4 numbers, they could be 100 numbers, or they could be infinite to where they go on and on. Okay, let's look at the second one. Hopefully this won't take too long. This time, what is our function rule that we're gonna plug into? And to the 2 plus 1. So if I'm listing the first 4, I do 1 squared plus 1. What would that come out to be? 2 total. Okay, then I do 2 squared plus 1. What would that come out to be? 5. This 2 squared is 4, plus 1 more is 5. Okay, what would my third term be? 10, yes, that's right. 3 squared plus 1, which is 10. And then for my last term, it'd be 4 squared plus 1, 17. And then to write out your sequence, you just take those exact numbers, put them in order. So it'd be 2, then 5, then 10, then 17, comma, ... Okay, we can do that pretty easy. Okay. There are 2 special types of sequences, and the name is going to depend on what the pattern is. So they can be arithmetic. And arithmetic is going to be when your pattern is a plus or a minus pattern. So if you're always adding or subtracting, okay, the same number, it's considered arithmetic. Versus geometric is the second type. And a geometric sequence is when your pattern is one of the other 2 operations, which are what? Multiply or divide. Okay, if you have an add or subtract pattern, you are going to call that pattern a common difference. We're going to use the letter D for that. And if it's a multiply pattern, you're going to call it a common ratio. You're going to use an R for that. So we have 4 very easy sequences at the bottom of the page. We're going to figure out if it's arithmetic or geometric, and then if what the common difference or ratio is. So look at the first pattern. It's a 6, then a 10, then a 14, then an 18. What are they doing every single time? What's the pattern? Adding 4. And if they're adding every time, is it arithmetic or geometric? Arithmetic. So I'm just going to put an A. And arithmetic means that it's a common difference. And the difference is plus 4 each time. Okay, let's do number 2. My numbers are 10, then 20, then 40, then 80. Then 160, what's the pattern? Times 2, and if it's a multiply pattern, is it arithmetic or geometric? Geometric. And instead of a common difference, I would put a common ratio of times 2 each time. So remember that difference refers to plus minus patterns, ratio is a times divide pattern. Okay, we're just gonna do one more since this is pretty easy. Okay, number 3, my numbers are 180, then 60, then 20. What are they doing each time? Okay, is that arithmetic or geometric? Divide by 3 means geometric. And then for your ratio, you can't put divide by 3. You still have to put a number. So what fraction would be the same as dividing by 3 every time? 1/3. Okay, so you're always gonna put a number multiplied, but if it's a divide pattern, you would just use a fraction to show that it's dividing. Okay, and then we're not gonna do number 4 just because it's easy. We have several examples. So go ahead and turn the page. We are gonna learn how to do the arithmetic and geometric formulas separately, but we are gonna do them both today. So the first one we're gonna cover is arithmetic. What type of pattern is that? Arithmetic is which operations? Plus, minus, addition, subtraction. Very good. So here's your general formula at the top. Okay, any formula will be whatever the first term is, plus whatever the common difference is, n minus 1. Now, I want to talk about the n minus 1 for a second so you'll remember why that happens. For the very first term, I want it to stay this number. So do I want to add the difference for the first number? If I want it to stay the same? No. So the n minus 1 protects the first number so that you don't add, let's say it was like the plus 4 pattern, so that you don't add the 4 yet. You're going to keep the first number the same. And then for every term after that, you're going to add 4. So that's why this minus 1 is. Okay. All right. So let's look at number 1. Can you tell me what the pattern is? 1, 5, 9, 13. Okay, the pattern is plus 4 each time. That's your common difference. So then my A sub n is whatever the starting number is. What's the starting number to the sequence? 1 plus 4 times n minus 1. And that formula will tell you any number in the sequence without you having to write out the whole list. So the question says, find the 20th term in the sequence. You have 2 options. You can keep adding 4 until you get to the 20th number, or you can just plug in 20. So you would label it A sub 20 is 1 plus 4, 20 minus 1. And again, why are we only adding the 4, 20 minus 1 times? Because the first number needs to stay a 1. And then I'll add 4 by the second, third, fourth, fifth time. Okay, put it in your calculator, tell me the number. So 1 plus 4, 20 minus 1 in parentheses. 77 is correct. Pretty easy. All right, take a look at number 2. Okay, let's find the pattern. 7 to 2 to negative 3 to negative 8. Minus 5 is the pattern, correct? So from here to here, we minus 5. We're going to call that the common difference. And then my formula or function rule is going to be whatever the first number is, what did it start at? And then I'm going to minus 5 each time, but not the first time. That's where the n minus 1 is. Okay, they're asking me to find which number in the sequence. The 30th. So I can either extend the list out to be 30 numbers long, very annoying, or I can use the formula, plug a 30 into that spot, and then tell me what that number is. So it'd be A sub 30 equals 7 minus 5, 30 minus 1. Pretty easy. And I got negative 138. Or you think, Martin? Okay. Alright, take a look at the next question. Now, if they give you the list, okay, obviously it's like best case scenario, cause you can just subtract the two numbers next to each other to know how much it grows by. Okay, but what about like on number 3, if they only give you A1 and A11? And your numbers aren't really next to each other in the sequence, you just know 2 random numbers in the list. To find the difference. We are still gonna use A1, but we have to find the difference, and the problem is our numbers aren't next to each other. So here's what you're gonna do. You're gonna do AN minus AM over N minus M. Now, here's what that means. You're gonna subtract the 2 numbers, and then you're gonna subtract the 2 mini numbers. And then you're gonna divide them. So for this one, I have A1 and A11, right? So I'm gonna do A11 minus A1 over 11 minus 1. What is A11? What number? 52. And 52 minus, what was my A1? 22. So question, how much did it grow if it ended at 52 and it started at 22? What's that difference there? It'd be 30, very good. Now, how many terms did it take to grow those 30 points? Well, 11 minus 1 is how many? 10. So if it grew 30 points, but it took 10 numbers to get there, then how many did it grow each time? 3. Does that make sense? Okay, so the formula makes it seem more complicated than it is. But you just subtract how far it jumped and then divide it by how many jumps it would have taken to get. Okay, from there, my formula is A1. What's my A1? 22 plus 3 and minus 1. Okay, so you have a little more work to do to get your difference, but then other than that, it's pretty much. Okay, then I want the 13th term in the sequence, then we can just plug in 13. Well, this is already solved because we don't have a specific number yet, but then in the second part, when you want the 13th, that's where you solve it. So for my A sub 13, it would be 22 plus 3 times 13 minus 1. Now, somebody in the other class had said, well, if I already know 11, can I just add 3 twice to get to 13? Sure. So if it is that close to one of the digits you already have, that'll work. But if not, then just plug it in. So tell me what that number is, please. Perfect. Okay, you have one more like that. Can you find the difference? We said this was 58. Okay, notice, are your terms consecutive, meaning they're right in a row? Then you're gonna have to do that little formula that we did. So to find my difference, I'm gonna do 18 minus 15 divided by what? Give me the formula, not the answer. It'd be 18 minus 15 over what? 13 minus 7. Because you're trying to figure out how much did the number change and then how many terms did it take to do that. What is 18 minus 15? So it grew by 3. What's 17 or 13 minus 7? 6. And what is 3 divided by 6? A half. So that means this is the cutting or a half. Add a half pattern each time. Okay. So my difference is plus 0.5. Okay, now be careful. I actually just said it wrong a second ago. It's not a cut in half pattern because that wouldn't be arithmetic, right? Arithmetic is only add and subtract.
So
It would have been geometric if it was a cut in half, but this one's not. So I'm gonna add 0.5 each time to get to the next number, okay? So let's write our sequence. It'd be a sub n equals whatever my A1 is plus 0.5 n minus 1. Now, I want you to notice that we have a little bit of a problem this time. Okay, what number do I need to know to put in this spot? I need to know the first term. And what terms did they give me? They gave me number 7 and number 15. They didn't give me number 1. But you can still find the first term. You're just gonna have to do a little bit more work. So look what it says right here. If you were not given A1, you can find it. Just use the function rule and one of the other terms you do have. So do you want to use A7 or A13? It does not matter. So 7 sounds good. What is the answer for A7? 15 equals A1 plus 0.5, 7 minus 1. And then we're basically gonna just like have to work our way backwards to what that first term would have been. So what is 7 minus 1 in the parentheses? That'd be 6. What is 0.5 times 6 or half of 6? So then 15 is A1 plus 3. And then if I'm trying to solve for A1, what would I do to get rid of the plus 3? Just subtract it across. So my A1, my first term, must have been 12. And now that I know what that first term is, you can also like think about if I started with 12 and I added a half each time, does that make sense? It'd take me 7 terms to get to 15. And you can just kind of like think about if your answer makes sense, which it does. So let's rewrite our AN here. 12 plus a half each time, but not the first time. Okay. Then it asks you to find the 4th term, but you can do that, so we're just gonna skip it. Okay, do you feel like you can do that? All right, so go ahead and pull out, we're gonna do your notes in half. So you can do the first half of the homework. I'm gonna show you where to stop. So pull out your adult math. Also, I copied your packet where every other side is scratched, because I don't know how to copy scratch things. So I'm not gonna pass out scratch paper, just use those back sides.
Your face. That's what it's called.
Okay, your stop button or your stop question should be right here. Go all the way through the first half, through all the arithmetic, and then stop, we'll do the second half.
I just said. I feel like.
Okay, so this is your first question, yeah?
So first question, what's it growing by each time?
Okay, so your common difference should be 4. Okay, then let's write your formula. A sub n equals.
Remember, we have to start with the first term. What's the first term?
6. And then we're gonna add 4 each time, but not for the first one.
Okay, and then what term do they want you to find? The 30th, then what are you gonna do with the 30? Just sub it in.
So you'll do in the calculator, A sub 30 equals. 6 plus 4 times 30 minus 1.
And then just put that into the calculator. Okay, and you don't have any of the hard ones where you're like missing the first term, so they should all be pretty.
2022?
Will sleepy today?
No, it's not. What is it? Dude. I went into the.
Yes, sir. Uh-huh. Put this first term, what's your first number? 7 plus 8 to the n minus. And then
The
we'll plug in
absence
the
of
brain.
it's just a message, where you be like, it's out. I feel bad for everything.
Okay, go ahead and take a look at your next page, please, of your notes. Okay, the multiply patterns are extremely similar. There's just a little bit of a difference in the formula that you're gonna use. Okay, so if it is a geometric sequence, what is the operation type for the pattern? It is an R and it's multiplication or division. So your sequence, you're gonna start with A1, but you're gonna multiply by R to the n minus 1. So you'll notice it's almost the same thing, except instead of adding a difference each time, you're multiplying by an R each time. Then remember, the n minus 1 is what protects that first term so that it stays the same. So if I'm looking at number 9, what is my multiplier on number 9 each time? It goes from 10, 30, 90, 270, 3. So your ratio is gonna be 3. That means that your sequence would be whatever the first number is. So it would be 10 times 3 to the n minus 1. Okay, and then let's say that I want the 10th term, then I have two choices. I can extend my list out to where I have 10 numbers in a row, or I can just drop the 10 into the end spot, and then I can shortcut to what that 10th term would be. So it would be 10 times 3, 10 minus 1 times. That is a 10, that looks kind of ugly, but. Okay, then put that in your calculator. Also, keep in mind, if you're timesing by 10 times, your number's gonna get big pretty quick. Okay, so your geometric sequences are gonna grow a lot faster. Okay, did y'all get that? Uh-huh. It'll be 196,800. Okay. All right, take a look at number 10. Will you look for the pattern, please?
Minus.
Divide by 2 each time. And if the pattern is a divide by 2, what ratio would you use? A half, very good, or 0.5. Okay, because remember, you have to write your common ratio as a multiplier. So if it needs to be divided, you're gonna use a fraction for that. Okay, let's write our a sub n. Whatever my first term is, what's my first term? And then I'm gonna do 1/2 up to the n minus 1. Okay, in your calculator, we're gonna find the 8th term in the sequence. So I would do 80 parentheses. 1/2, use your pretty fraction, please, up. So the n minus 1 is now going to be an 8 minus 1, because we want the 8th term in the sequence. Okay? So it would be 80/2, 8 minus 1, which is 5/8. Okay? So just like they get big really fast, they can also drop really fast because they're essentially exponential. Okay? All right, we're just gonna do number 12 next. We're gonna skip 11 just because it's really similar. So can you look at number 12 and see if you can find the multiplier there? How did they go from 3/2 to -9/2? -3, very good. Now, when they times by -3 the first time, it turned it negative. But then if they times by -3 again, how does it come out?
positive, and then if you times by another negative, it's back to negative. And so it's gonna flip back and forth between positives and negatives. So this is a multiply by -3 each time, that's your ratio. What's the first term of my sequence? So 3/2 here, -3 is my ratio, but I'm only gonna multiply it after the first term. That's what the n-1 is. And then if I want the 8th term in the sequence, I just pop an 8 into the formula, and then I don't have to keep recursively doing that same pattern over and over again. So 3/2, -3 up to the 8 minus 1. So I got -65/61/2. Oh, y'all got? Pretty easy? Okay. Alright, last question, number 13. Okay, this one, you're not given the first term, but you are given A3 and A4. Okay, so quick question, is there a clear multiplier to go from 18 to 48? Do they double it? Do they triple it? No, so it's gonna be some kind of weird fraction. So if you have to find your common ratio and it's not something really obvious, you're just gonna divide second over first. So remember, like with the arithmetic, if you didn't know how far apart they were, you could just subtract to find out how much they added. So same thing here, if you don't know what they multiplied by, then just divide. So in your calculator for your ratio, you're gonna divide A4 by A3. Okay, a lot of them for your practice, it is gonna come out to a nice easy whole number, like they're doubling it or tripling it. Okay, but this one, 48 divided by 18 doesn't come out that pretty. So 48/18 comes out to 8/3 for your ratio. So then if I wanted to write my A sub n, I would say, okay, well then A sub n equals whatever my A1 is times 8/3 to the n minus 1. But then I notice that I have a problem. What term did they not give me? They didn't give us A1, but they did give us other terms, and we can still work our way backwards, just like we did on that other example. You can use either of the terms they gave you. Do we want to use A3 or A4? It doesn't matter. Just somebody pick one. A3 sounds good. But you could use A4, doesn't matter. So we're gonna use A3. What is the answer for A3? 18. So I would do 18 equals A1 8/3 to the 3 minus 1. Okay, but remember, I could have used either one that they gave me, it doesn't matter. What is 3 minus 1 on the top? 2. Can you put 8/3 to the 2 in your calculator? So you're gonna have to put it in parentheses, 8/3 and squared. Now, quick note, just because in the spring, I think y'all do some TSI type stuff. If you're squaring a fraction, you just square both parts. So the 8's gonna turn into a what?
16.
That little square,
64.
64, and the 3's gonna turn into a 9. So this is gonna be a 64/9. And then how can I get rid of the 64/9 multiplied with the A1? Multiply by what? Well, okay, I'll tell you. This is, so your A1 currently, it's multiplied by 64 and divided by 9, yes? So I wanna do the opposite. I'm gonna multiply by 9 and divide by 64. What do we call that? It starts with the R. Reciprocal, yeah, that's how you get rid of a fraction. So if it's A1 times 64/9, I'm gonna times by 9/64. And if I do it on that side, I have to do it on this side as well. And that'll eliminate the fraction, so your A1 is solved. Okay, so in your calculator, what is 9/64 times 18? 9/64 times 18. It's a fraction. So your A1 is gonna be 81/32. Okay, which is a pretty weird start number, but that's what they would have started their sequence at. So then now we can fix this right here. Your A sub n would have started at 81/32. You're multiplying by 8/3 each time. Okay. And then if it asks you for a particular value, like the 100th term, you could just leave it. Okay? But I will tell you that doesn't happen on your practice. The practice is all you have the first. Okay? So go ahead and finish that up. Yes, take the basket.
Right.